Yeah, warm good afternoon, class. This is another video about heat treatment. In the previous video lectures, we have seen the first part of heat treatment, where we have seen about what is basically a heat treatment, and what we have seen is annealing part, right? So in the annealing part, we have seen what is annealing, what is full annealing, and what are the types of this annealing, and what is the main objective to do the annealing for a particular material, right? So in this class we are going to see the next part of heat treatment, which is nothing but the other heat treatment types, right? So the first one, apart from annealing, I like to discuss about is it is nothing but normalizing. Okay, so here you can see, as its name implies, it's normalizing. Here the annealed part or the heated part is removed from the furnace, means that here you can see, there are three steps in heat treatment, as we discussed, that is heating, holding, and cooling. So here in annealing part, the cooling takes place in the furnace itself. So there will be a very slow cooling part, and the cooling rate is very low. Means we can say for 1 hour it may be 10 degrees Celsius, there will be reduction in the heat. So cooling is around 10 degrees Celsius per hour. But in normalizing, here you can see in the normalizing part, you can see here the annealed part is removed from the furnace, means the heated part is removed from the furnace. Here the cooling happens in the normal still air. So it here the particular specimen or a particular piece which is heat heated, here the cooling part, the third step cooling part takes place in the normal air. So it is known as normalizing. So here when we come to the main objective, it is more or less similar to annealing, as like we have to remove the strains, remove the internal stress, remove the dislocations, and to improve the mechanical properties like strength, hardness, toughness, measurability. But here you can see in the normalized part, you can see here you can see the parts where you can see this is not properly arranged, it's in a heterogeneous manner. But upon normalizing, you can see is a homogeneous, properly arranged microstructure for a properly arranged microstructure. So this properly arranged microstructure helps to improve the mechanical properties of a material. Here it is, this microstructure is nothing but the casted connecting rods microstructure before normalizing and after normalizing. So this is the here from normalizing, next we are going to see about hardening. As the name implies, it is used for hardening purpose. So we are going to increase the hardness of a particular material. So hardness is nothing but the resistance towards wear or scratch. So once a material is hardened, okay, it can be used for the applications where high hardness is required. So the particular part is hardened. So in here, the main purpose of hardening process, that this particular heat treatment is helps to produce the martensitic microstructure. As we like in Tamil we can say nerinjimul, right? So if we take that nerinjimul thorns as in a plate, if we keep in a plate in a disordered manner, so that is the that looks like a microstructure of martensite. So you can see this martensite is produced based on the hardening process. Here the main objective is that to improve the hardness and improve the wear resistance is the main objective of hardening process. Here you can see this hardening process. When we speak about production of this martensite, here the hardening happens like heating, holding, and cooling process. It is suddenly cooled, means that we are using either cold water or running water or brine solution. So here the cooling takes place suddenly. So this rapid cooling helps us to produce the martensite in a particular microstructure, right? So here you can see heating, soaking, and again it's form as cooling. So here there are these factors where the hardening can be affected. One is carbon content. High carbon means high hardness. So adding any type of alloys, particularly carbon, increase the hardness in naturally. Quenching medium, faster the cooling means faster the cooling, greater the hardness. If he slowly cooled, martensite may not form. If he cool it fasterly, hardness the martensite forms, so hardness gradually increases. Increase the specimen size, decrease the hardness means if a complex size, if a big complex size we are using, complex sized component is using, we are using for heat treatment, then due to there will be heterogeneous, there will not be any homogeneous heat treatment, so hardness gradually decreases. So these are the factors where other factors like geometry, quenching medium, DRF agitation, surface conditions, alloying elements, where these are the factors that affect the hardness, right? So we'll see the rest of the we have to see tempering process in the next video, right? Thank you.